Right, so I will tell you, because I was quite lucky to be at the beginning of smart contracts, of how they were created and the whole Ethereum ecosystem. And I was at the beginning there when we were just discovering how to build contracts and how to build code that manages money and how to manage the fact that someone chose JavaScript as a basis for the whole financial ecosystem. Like the whole of Ethereum, and I guess Ethereum, you know Ethereum or Bitcoin? Yeah, you know? Yeah? Okay? Like the whole of it, like all the smart contracts that manage millions or billions or trillions of money are being managed by a code that is written in Solidity, a language that is based on JavaScript. And that is insane. If you know, I'm sure that you love JavaScript, but not that much to trust it your own money, right? So that was a brilliant idea, and it caused a lot of fun situations. But before I get to those fun situations, I will tell you a few words about how smart contracts work. And you know, I will try to make it as simple as possible. But first of all, like, how many of you know smart contracts, blockchain? Okay, some of you. Okay, so bear with me, and then later on explain it to the people that don't know. So a model that you could think of, and forget about all the cryptocurrencies, forget about everything else. Imagine that you have a box, like a virtual machine, okay? Like you have one computer somewhere there in the cloud, like one, right? One computer. That computer, anyone, literally anyone, no permissions needed, they can throw their script onto that computer and it will be run, all right? So there's one computer and like scripts for millions and millions of anonymous people that can just do anything there, right? Some exceptions, but that's the basis of that. Now, the cool thing is that this script can have money. So a script can have like its own purse or wallet, and it can have some money. Sometimes it's $5, sometimes it's $5 million, but your script can have money there. And other scripts can call your script and ask, oh, you promised me some money, like please give me that money, right? Or whatever else. And like your script can have some functions that are public that other scripts can call, and you know, it can execute some things, right? So that's more or less that. Now, all the data in that machine is public, so anyone can see the sources and the memory of all the scripts, and anyone can try to analyze the scripts and find holes in those scripts. And the other thing is, you cannot change the script. So unlike web development, once you upload that script, if it manages, it doesn't matter, $5 or $5 million, you know, it has that wallet, it has that purse, and it's neither you nor anyone else can change it anymore. So if you made a mistake, like the money will be gone, or like the script will not be able to be changed. Like there are some ways, but it's complicated. And like in general, if you make an error, it is costly, right? So again, a public machine, anyone can see the script, anyone can run the script, anyone can exploit the script because it's totally anonymous, and it's all running on a language that is based on JavaScript, and that's you know, it will never fail to amaze me. Anyway, I was there at the beginning, and I was lucky again enough to meet some people that designed the language, that worked to improve the language. I was also lucky enough to meet the people that lost like hundreds of millions of dollars because of the bugs on the language, and you know, it was fun times. I left 4 years ago, but it's nice to share that experience with you. And you know, JavaScript, you know, we have JavaScript, you have TypeScript, you have other variations of JavaScript, but I'm sure there are some lessons in you know, designing and trying to figure out how to make a language that doesn't allow you to do too much, or making a language that will prevent you from making some stupid mistakes. I'll give you the first example, and that was fun times. That was half a year after Ethereum launched. So, you know, we have a script, and I know it's complicated to explain this to people that didn't work with blockchain, but I will try. So we have a script, right? A long script, and that script has a function called withdraw, right? It allows you to withdraw the money from the script. You know, and you know, you type in, you call the function, your script calls the function, it provides the amount to be withdrawn. Then you know, the script checks what's your balance in the internal memory, right? So it has an internal memory that says, this other script, you know, I owe it $5. This other script, I owe it $10. This other script, I own $100, whatever, right? And if your balance is, or your script's balance is higher than the amount, you know, it sends you that money because it owes you and you deserve the money, right? And then it removes the balance, right? So it lowers the balance, right? So yeah, like that part of code lost people $70 million. That was fun times in one day. I wonder if I know that you're not proficient with the language, but I wonder if you can figure out where's the mistake here, or where can you have a mistake? Similar, not necessarily negative. Yeah, but you're right there that it could be a negative amount. That would be the slide number 4, a different exploit. Yeah. What else?
Balance was not reduced.
Yeah, a little bit. So the thing that you may not know because you don't know the language is that send money can have a callback function, right? So if you call the send money user amount, then there's a special callback function that brings the execution back to the user. All right. So the idea is your user or your script calls this withdraw function, then this withdraw function sends the money to you and calls your callback function. And what can your callback function do? It calls withdraw money again because the balance wasn't decreased before that. So it's just an infinite loop of sending you money before the last loop just removes it once, right? So that's more or less what happened. Is that kind of understandable? Yeah. So that was fun times because due to technical reasons, it couldn't be withdrawn all at once, but it was a very, very fun day for people because then there was this script called the DAO that raised accidentally, I kid you not, $70 million, and then they see that the account should say $70 million, but it's 68 and 67, 66, and you could see it minute by minute, hour by hour, losing like millions of dollars, right? And debugging that's where you feel the pressure. You see that there is some kind of a bug and you lose $1 million a minute or every 10 minutes, and you need to figure out what's going on. And of course, once people figured it out, like there were white hackers who also ran the script in a similar way, trying to steal the money before the main hacker did. So it was like a whole race of doing that. And the thing is, with Ethereum and with blockchain in general, you cannot turn back time. But in this single case, it was such an impactful thing, it would break the whole network that right now is still running, that they said, okay, this single time, like this is so bad that we will turn back the time and we'll pretend that this contract didn't exist. That happened just once, and they never, even with bigger issues, they never did that again. So anyway, that's the mistake that happened. The question is, of course, like the programmers were terrible. Like, how could they not see that, right? And where was the quality control? But the question is, like, what could the language do, right? And right now, as far as I know, because again, I've been out of the field for 4 years, what happens is, like, the team has learned and essentially allowed to create functions that have this parameter, non-reentrant. So you can have something like a function that says, oh, if you run this function, you cannot, it's slightly different code, but the concept matters. If you run this function and there is a callback, the callback cannot get back to this function, right? So it doesn't prevent all the mistakes. You can still mess up the code, but at least, like by design, like it's way easier to protect from this thing, right? So it's way harder to make a mistake now. And of course, it makes sense to, first decrease the amount of balance and then send people the money. That's kind of obvious. And also, I remember discussing that with some other people that tried to build another language, and they said, oh, in our case, sending money, like the language requires all the send money instructions to be at the end of the function. Like, that's it. You cannot do it any other way. So, they decided to limit the developer's ability to write a function, but just to avoid a certain kind of mistake. But that was a different language, that wasn't Solidity, it didn't pick up, and yeah. Anyway, so that's one of the 4 cases that I will show you. That was the funniest one because yeah, like that was the first one. And I still remember a very cool guy was doing the PR for the DAO, and he's always smiling on his face. So imagine trying to, with smile, explain to people that like $100 million is gone because of a bug in that contract. That was fun times again. So there was another one, and it's a simple function, so I will need to explain it slightly more. Here it was 150 million, so the community learns, it's bigger and bigger mistakes, right? And the function, it's a long story, so it's slightly more complicated, but there was this big wallet. There was this one script that held money for like thousands of people, right? So it held money, and I'm simplifying, so if anyone is watching that from the community, it's not exactly how it works, but trying to simplify it. So there was this one contract that was holding money for like thousands of people. Altogether, it was $150 million, right? And that contract, every script, needs to be initialized at the beginning, right? So there was this function called initialize that set admin of this script to a certain person. Admin had like certain privileges, very little, very few, so the admin couldn't take away the money. But among other things, it could turn off the script and just log the funds and remove the funds and everything, right? So there was this function, initialize. But what they missed is that they made the function not, if I'm not mistaken, not as a constructor and not as a private function that could be run only once when the script was initiated, but they made it a public function. So it was created once, and then anyone at any time could become an admin by just calling this function, because they kind of missed saying private here, right? and the constructor. So that was quite fun, especially because that was one function. The second function said, oh, the admin has the ability to kill the script. So there was a function called, I don't know, destroy or kill or something like that, and that checked correctly if you're an admin, and if you called that function, just poof, like the money is gone, like everything is gone, right? So someone posted, as far as I heard, on GitHub an issue saying, guys, I think you have a mistake. That was a public issue, right? Like you can call these two functions, first initialize and then destroy, and everything will be gone, I think, right? And then like a few minutes later, as far as I heard, some other guy said, oh yeah, I tested it, it's gone. And poof, like $150 million gone. Well, it's not gone technically, it's still there on the blockchain, like all the $500,000 of Ethereum. So right now it's worth, with the current prices, it's around, how many, like $2 billion or something like that. So it's still there, it's super safe, just no one can touch it ever again, right? And these guys also said, well, no, come on, it's the beginnings, like give us our money back, please, Ethereum Foundation. But Ethereum Foundation said, no, like we told you, like that first hack, that was the only time we did it. We cannot just keep rolling back transactions if you mess it up. So the money was gone, and it's gone forever. It killed the project and whatnot. Yeah?
Did they roll back transaction, or did they fork the blockchain?
Oh, so with the first case, with the DAO, yeah, like I try to simplify things because it's short presentation. Rolling back transactions mean that you create a new network so you build a new machine that is exactly like the previous one, just without this one thing, and you say, oh, this is this thing, that like this is the Ethereum now, right? The other one, like let's ignore it. It works, but like it's not Ethereum, right? So that's how you kind of roll back the transaction. You just make a copy of the whole thing.
And you have Ethereum Classic to this day.
Yeah, exactly. So the original machine is still working. There are people saying, oh no, this is how it works, this first box, right? But like the world has moved on. But for a while, it was like everyone that had money on this one had also money on this one. And just, this one was less worth and this one was worth more. Yeah, but yeah, that's exactly that. Later on during the break, I can tell you all the details and I can give you like an even longer explanation. So anyway, like I think that also can be prevented by the language. And again, if anyone knows Solidity, I apologize because like it's probably completely messed up. But more or less what happened is that right now we have constructors that need to be explicitly said constructor, not something else. And also, as far as I know, right now it is obligatory to say, oh, this function, aside from constructor, this function is public or this function is private. So we do not have situation like this where it's like, oh, someone missed it, some other person didn't also missed it when reviewing code, and it's suddenly public. So we have to always explicitly say public, private, and whatnot, right? And constructors also, like, you need to define clearly. So that's another case where it cost a lot of money to people that like the language allowed slightly too much, and that was fun. Now, two more cases they don't have big hacks behind them. They have like thousands probably of smaller hacks. So it's even harder to say how much money was lost, but it's still quite interesting to see. This thing. So it's like two more slides. I hope that you don't drift away. This is something that wouldn't happen in JavaScript. The thing is with the smart contracts and this language Solidity is that it's it is statically typed, and the integers, the numbers, have a limit. It's a very high limit, but it's a limit, right? It's a limited amount. So with JavaScript, as far as I know, if you cross the limit of integers, it just says infinite, right, or something like that. So you cannot really go overboard. And here it's like the old school programming. So if you cross, if you have a number that is way too big, it just rolls back to this negative number or zero number, and it just goes again and again in a circle, right? So there was this contract, and it's not just one. Probably it was thousands. Sometimes it was people just on purpose did that kind of mistake to steal money. Where it checks again, like you call a function on your script that says transfer, to whom the amount, right? And on the face of it, it looks legit. It says if the balance of the sender is smaller than the amount, throw error. Otherwise, decrease this amount, increase this amount, and like send money or whatever, right? But just this looks totally legit because it checks if you have enough money on the account, right? It decreases, it increases in the right order. The problem is, sure, but if your amount is a certain number, I forgot what that was, or something like that, it will overlap, or if you provide it with a negative number, I cannot, its memory is a little bit shady, but more or less, if you call it with the right parameters, it will just have an overflow and it will give you infinite money. Like in old video games, I don't know if you played Transport Tycoon or something like that, you built a long enough tunnel and you get infinite money because it was so expensive that it went into negative. So, I'm not sure if exactly this code is buggy, but I want to show you the idea behind it, right? So perhaps it's plus, minus, or something like that. How can it be improved? Well, that's simple. Again, JavaScript doesn't necessarily have this problem, but Solidity had. The simple thing is make the range checking by default on, right? Like so if you go overboard, it's just the whole function says cancel, like it didn't happen, error, like rolls back everything, right? So just a simple thing, but it's again a language design decision that turned badly. And actually right now Solidity has, as far as I know, this range checking by default on. It is slightly more costly because you need to do more calculations to perform that, but that should be there in the first place. The second mistake, and that was the stuff that I did. My most recent project in the blockchain was I built a decompiler for contracts. So actually, I figured out from bytecode into source code how contracts work, and I found this gem. And I know it's a lot of code, again, different language, but I showed it to the people that did audits, code audits, and they couldn't see what's wrong here. And the funny, it's super easy for a human to miss. It also checks the balance, right? If the amount is something, then it calls assert fail, right? And then assert fail throws error, right? Otherwise, it does this. And the question is, perhaps someone of you might figure out, I know it's a different language, but perhaps you may figure out what may be wrong with this code. Exactly. Assert fail is not called because you should have quotations here, right? the parentheses here, right? So this does nothing, right? And when I found it, my decompiler analyzed a lot of contracts and they look at it and says, what the hell? Where is the bug here, right? Well, it's not called and it's super easy to miss by a human. And in word to word, do you need actually a structure where you can call this, do something that doesn't make sense, right? Doesn't do any effect. Of course, in C++, in many languages, you can do that kind of things, but it just causes mistakes and problems to people, and that costs people money. And actually, I found some contracts where people were exploiting that actively. It wasn't big contracts, just hundreds of dollars, but I could see someone just having that bug ready in the code, so they could steal the money the moment people would put more money on that. And I found some contracts that actually stole people's money because people could see the source code, but even experienced auditors, it was very easy for them to miss that part. Okay, I can see that I will compete with pizza again now, but I'm very happy that it will be almost the last slide. Yeah. So final thoughts. Perfect timing with the pizza. Final thoughts. Again, experience from Ethereum. I know that not all of it relates to the JavaScript, but in case of Ethereum, in case of financial things, tests give you virtually nothing. In a world where one mistake you cannot roll back, first of all, and one bug open source bug causes you to lose the whole of your project, a lot of money, and it can be exploited so easily and anonymously, like tests will not give you much, right? Because post factum, sure, or if it's low stakes, sure. If it's closed source, sure. But in these cases, tests give you very, very little. And Ethereum community realized that quite fast, so they moved into formal verification. So this is like math, analyzing code and logic behind that, and static analysis, trying to figure out if there is a mathematical proof that the code works. And it's slightly different than JavaScript because also smart contracts are way simpler, so it's easier to do. But for many contracts, there is a mathematical proof that they actually do what they are supposed to do. So that's one thing. Then language improvements happened over the years, and I discussed it, with a lot of people, like how can we improve the language. So I showed you a few examples. Now, checking invariants. I know that some developers don't use asserts, and in many languages, asserts don't do much. But in case of Solidity, as far as I know, right now you can type in assert, so you just have a special check, and of course it may fail during the runtime, but also there are special tools that check if there is ever a possibility, like mathematically speaking, or analyzing code, that this assert will fail or will not fail. And finally, of course, code audit. So there are companies that verify the code, but it's always does it work, does it not work? And here I have a nice quote from someone that was running a very big enterprise, like with builders and whatnot. And he said, it's okay if someone dies as long as it's according to regulations, right? So it's okay if your contract fails as long as you have audits that prove that it was okay, because then it's auditor's fault. So that's how the community handles that right now. And we have less and less mistakes, I hope. And it's been an exciting adventure also being at the beginning. And if you ever have a chance, I highly encourage you not to go into blockchain, but go into a field where you get the chance to meet the brilliant people that try to figure out what works and what not, and meet the people that make these stupid mistakes, because it's an awesome feeling, and also awesome feeling to discuss with them what can be done to avoid these mistakes in the future. So thank you very much, and questions and answers 1 minute, and then pizza. Thanks. Yeah, any questions?
So the question is, as you told that one bug can cause a loss of $1 million. So who is responsible for it in the end? Like if somebody will cover that cost, or how it usually happens?
It depends, right? So the question was again, who's responsible if the bug causes a lot of money, damages and whatnot. So at the beginning it was there was a sign saying beta, right? And that's sorry, it's gone. We tried our best, right? Sometimes there can be projects that are responsible, but usually it's saying, if you put money here, it is beta. It's super risky, right? So just be careful. We're doing the best we can, but just, sorry. Projects, there were cases where projects refunded or tried to refund, but it's always a difficult part, because if a project crowdfunded $100 million and they lost it, and you could see that honestly they lost it due to a bug that it looks that it was an honest bug, there is no way for them to ever recover it, right? So it's a sad situation, but everyone lost there. But there are also cases where the community sees that is bullshit, that's not an honest mistake. Obviously that was planted, or we have strong suspicion that there was some foul play there, and in that cases, it's usually just legal recourse towards the person. But again, the upside and downside of this whole thing is that it's a very fluid system, right? The money flows very fluently. It's nice because you can program it. It's nice because you don't need permissions. You don't need to ask banks for permission to do anything. Downside is, if it's gone because it just flows so fast, right? Just trying to prevent the code from executing, right? So it's complicated, but yeah.
Thank you.
Thanks for the question. One more? Okay, we have one more.
I'm wondering, what was the atmosphere in these companies regarding the security? Because those bugs sound like they are maybe not very easy to spot, but for a really serious effort, if you were a bank and have QA, security and everything, it would be rather spotted. So was it people were, oh, it's fun and let's do it fast? And
so just to repeat the question, what was the atmosphere? Oh, it was insane, right? But the thing is, the thing with bugs is that they oftentimes look obvious in retrospect, right? So we had famous bugs in open source also that look so obvious in the if you look, in retrospect, but they weren't obvious. Sometimes it took them 5 years, 10 years to discover, right? The thing with blockchain is that there is such a huge reward for spotting the bug that the procedure is different than finding a bug in Unix system or whatnot. The atmosphere was it was intense, but everyone tried to keep good spirits, and that's especially during the first year of operation, the DAO hack happened. It was like we are exploring the unknown. Like this is the first system of its kind that humanity has built, right? Like we don't know what we're doing, right? So if you're there, like your money will probably get lost if you're playing with this game, and like we'll do our best, but this is like we're experimentators, right? So we're these people perhaps behind right before the Wright brothers, or perhaps we are the Wright brothers that will build stupid things and we will fail a lot of times, right? So that was the atmosphere at the beginning. Although losing $100 million, that's painful, right? And I remember talking to people from Parity, like the people that lost 150 million, and that was their money, but also money of people that put their money on the wallet. And of course it was a sad thing, right? Like because you messed up seriously bad and people forgave them, but it's still, that was almost all of the project of the money that they crowdfunded, right? So now you have one day you fundraise $70 million and the second day it's gone, right? So how do you survive as a project? And for me, and I think for many people from the community, what shows they show a respect to those people because they didn't give up. They tried to regain money, right? And even if they failed, they still continued on with the project for many years to come. And they're a successful project, even though there was a huge setback at the beginning, right? But that's those cases. And then of course there are people that made mistakes that were just pure scammers, and like the community treats them totally different. But usually, it's difficult, right? And that's the price that you pay for being an entrepreneur. It's a super risky thing, and that's also why I didn't do my own ICO. I just built a decompiler and other stuff because I didn't have the balls to start a project, even a simple one like this, without a ton of legal protections and whatnot. And you need balls to have that. Like, sorry, that's not politically correct nowadays, but you need to have courage to do that, right? So that's the story. All right, I can smell pizza, so I guess I cannot answer any more questions, or is there one? No? Okay, I will be happy to answer any more questions during the break, and I guess that's it. Yeah, thank you.
Thank you so much.